What you guys have in front of you is the review packet. I need you guys to make one small change on that. So if you're looking at the front page of your review packet, it says it's due by December 15th. I mean 14th. So please make that change. Okay, so it should be the 14th that this is due on. So again, your final exam for all courses, 15% of your overall grade. Your final exam is going to cover chapters 1 through 5. Notice 5 is included, what we're working on right now. The equation sheet in the content library is going to be what's provided for you on the exam. So if you wanted to look at that, and you scroll through, it's like, 3-4 pages or whatever. It's all in there. You're going to get, I'm going to give you 2 to 4 questions per chapter. The exam format and the questions will be similar to those found on the review. So like the chapter 1 questions are all going to be labeled chapter 1 and all blocked together. Chapter 2 questions will be labeled chapter 2 and all blocked together. Each chapter's questions, except for chapter 1, will be worth a similar amount of points. There's less that I'm going to include from chapter 1. And here's the big one that you should really care about. If you turn in this exam review before the end of the day, the last day of regular classes, so 2:45, December 14th, you get 5 points of extra credit on your exam. And you can use the review on the exam. Here's the catch. I'm not publishing a key for this until 2:45 on December 14th. I'll be happy if you ask questions about it, to answer questions, but I am not giving you guys a key with my worked out solutions until after they are turned in. Why am I doing that? Because I really want you to do it and not just like copy down my stuff. I know how to do it really well. I want you to struggle bust your way through it. Now, before I turn it in, what would I do if I were you? Take a picture or make a copy of it so that as I'm studying and the actual review key is posted, I'd be like, oh boy, number 7, number 12, and then 17, I did wrong. I got to make sure I really study how to do those. So when the exam comes, I'm not looking at my wrong work and trying to use that to do something, right? Everybody's cool? Can you write down like instructions to yourself on how to do the problem? Yeah, for sure. If it's relevant to doing the problem, you can write instructions to yourself on what you should do or what to be careful of or like what to watch out for. You can be more general than that specific problem. Like it's okay, like I need to draw the picture. Remember that the picture that I need to draw, like I start by figuring out the quadrants for this interval. So I label going counterclockwise. You can write that stuff down if you'd like, if it helps. If it's relevant to doing that particular problem, you can do that, or that type of problem even, you can do that, include that kind of things on your review. That's okay. Does everybody feel pretty okay about the exam format and the best way to prepare? Do a good job on the review is what it basically comes down to. I've done this a couple of years now. If you do a good job on your review, you almost invariably do well on the exam. It's hard to, have spent good time working on that and then to not do well, especially when you can take it with you. But don't forget to turn it in. Mr. Kulik, is it okay if I turn it in before December 14th? Yes, of course. Be happy to take it and hold on to it for you, but well before then. Why am I giving it to you so early? Well, I assume some of you are going to probably start doing stuff over the weekend. I want to just make sure that I have it for you early. Mr. Kulik, what if like I lose this thing or my dog eats it or whatever? If you go in the content library, a blank one is in the content library also. You can always just print yourself a new one. I'm giving you a physical copy here because I'm asking you to turn it in or hoping you're going to turn it in. It's optional, but like, what kind of fool would not want to turn this thing in? That'd be a special kind of confident or a special kind of careless, right? All right. Everybody feel okay about the exam and what's going on for that? Okay. Feel like this is pretty fair, format-wise? Typically, this makes it pretty reasonable to do well. All right. Today, I want to start by, we haven't taken any questions yet from 1 through 7. So if you got, or 1 through 6, excuse me. So I've asked you to work on 1 through 6 already. We haven't taken any questions from there. We're going to start with that. Nick. Sure. All right. So number 4 says we want to find the values for all 6 trig functions using the identities or reference triangles. So we know secant theta is equal to 5. I can use R5 to show or to say that cosine then is 1 over 5. Should just be its reciprocal. I can then use P1 to say that sine squared plus cosine squared, but instead of cosine squared, I'm going to write 1/5 equals 1. Hi, Brooklyn. How are you? Good. Thanks. AJ, we have a pass, and then Billy Collins and Joy DeCasas, you guys have, looks like some kind of football-related letter because there's a football on the cover. You want to grab these things, fellas? So what do I get when I square 1 over 5? How do I square a fraction? Anybody? You just square the top and then square the bottom. So that's 1 over 25. I subtract, 1 over 25 from both sides. I'm making a common denominator. That gives me 24 out of 25. I do the square root of both sides. That gives me plus or minus, but I know sine is positive, so I'm going to discard the plus or minus. If I do the square root of a fraction, that's the square root of the numerator over the square root of the denominator, right? Well, I know the square root of 25 is just 5. And then 24, I know, is 4 times 6, and the square root of 4 is just 2. So far, so good. I know I can use R1 to rewrite, or to say cosecant then is going to be 5 over 2 root 6. And I should probably rationalize that denominator. So there's cosecant. That's 3. I still need what do I need? I need tangent. Well, using Q1, tangent is sine over cosine. I know sine is 2 root 6 over 5. Cosine is 1 over 5. I can reduce those and get 2 root 6 for tangent. And then if I apply R3, cotangent is the reciprocal of that. So 1 over 2 root 6. And I rationalize the denominator again. And I end up with root 6 over 12. And that's all 6 of them then. Counting the secant that I was given at the start. Does that feel okay, Nick?
Yeah.
So it's just like 1 and 2, you just keep going. Just like reciprocals and quotients and maybe a Pythagorean. But okay. We are going to today work on the homework, or the next set of kind of problems, the next set of homeworks. We're going to do it the same way we did the 7 through 13. So I'm going to divide you up into some random groups, and we're going to go around and kind of ask for some advice. Okay?
Sounds good. Building on the banner.
So you can get up and move by your partner, so you can sit next to each other, so you can converse.
Hey, Nate, have you done your note card? I'm not gonna go. Yeah, I have. Yeah, no worries. But and apple. No. Oh, really? I'm down. I can not 190.
All the way to the end. Yeah, 63 or something, I think. 62. All right. So this next homework assignment, or part of the homework assignment, is going to be 47 through 62. We're going to do as much of this as we can today as a group. Anything that's left over, you guys are going to be responsible on your own, just like last time. There's 15 problems. I think when we did this third hour, we finished half or so of it, which is pretty good. Yep. 62. Yep. So the plan here, or what we're doing in these problems, these are called verifying or a trig identity or proving a trig identity. Now don't be scared by the P word. Yep, that's the P word I was talking about. This is really no different than what we did last time when we did simplify the expression. In fact, I think that these problems are easier because you're told the answer. So when you're given a prove or verify problem, what we're going to do is we're going to take either the left-hand side and try to turn it into the right-hand side, or take the right-hand side and try to turn it into the left-hand side. The tools that we'll use to do that are going to be algebra or our identities. So it's doing the same thing really that we did last class, but here we have the answer. We know when we stop. And we can even use the answer as like a guide towards what decision should I make, right? Because you know what, in the end, what you're trying to make it look like. Okay? So the first thing that we need to decide before we get started is which side should we be working on, the left-hand side or the right-hand side? To be clear, there's not a wrong choice. The problem is doable either direction, but you can make your life simpler by choosing well. And I don't know about you guys, my life is complicated enough most of the time. I want to try to make it as simple as I can if I have the choice to do so. So in general, what I'm looking for is I want to start on the more complicated side. It's typically easier to take a bunch of stuff and make it smaller than to take a lot of stuff, or to take a little bit of stuff and expand it out, make it bigger, right? Most of us, it's going to be easier to think about simplifying things down and canceling things out than it is to like manufacture new stuff. So that's my first level of advice. So Nick and AJ, you guys are the first ones. If you look at the two sides, the left-hand side of the equal sign or the right-hand side of the equal sign, which appears to be the more complicated of the two? The left side. There's more trig identities on there. That's usually a pretty good indicator that that's going to be the more complicated side. That's where I would start as well. Nathan.
So in my mind, I was looking at it and I was thinking just distribute property on the left. Is that even like?
So that's an algebra thing, for sure.
So you could do that.
You could absolutely do that as a.
It would just be like
Nope. It's a fine idea. So again, this is the kind of thing that like would have been asking Nick and AJ about, but we'll start with you guys since you're already volunteering.
Because they said the right side. I thought.
No, they said left. Didn't you say left, Nick?
Means that we do the right side if the left side's more complicated.
No, we want to start.
Okay, I thought they said the right side.
Oh no,
So I was like,
they
do the left. All right.
yeah, they said left side, and we want to start on the left side because it's definitely the more complicated side. Yeah.
Okay.
You're good. You're good. So typically when we start, we're going to look for either algebra or identity. Now, Nathan, you've already identified that like I could do some algebra here by distributing the sign that's out front. And that's a great idea, because if I look at the right-hand side, do you see any multiplication going on the right-hand side? No. So at some point I know I'm going to have to do something about that. The easiest way to kind of take care of that would be to distribute. So let's do that as a first step. Now, what do I get when I multiply sine x and cotangent x? Yeah, we just write them next to each other because they're not like terms. And we do the same thing over here, right? So that's fine. All right. So Nick and AJ, Nathan stole the first step from you guys, but that's okay. Distributing is a good one. You could have also used an identity at the first step. It would have been fine. If you were thinking identity to yourself, that would have been okay also. What are you two fellas thinking now? Again, if you don't have your identity sheet out right now while we're working on these, I'd recommend taking that out so you have something to look at. So again, if you don't have your identity sheet out handy, at least one person in the group should have one out so you guys can both look at it at the same time.
If you change, I would use Q2, change the cotangent to cosine over sine, so when you multiply those.
It's a wonderful idea. Do you see another identity that you'd like to use here as well?
I guess you do the same.
With Q1, right? On tangent. Luca and Billy.
What's it say underneath sine at that highlighted green?
Cosine x.
So you want to cross multiply
The term you're searching for
not cross multiply,
is reduce.
Reduce the sine x and just make it cosine x,
Mm-hmm.
and then do the same thing with the cosine x, and then make it 2 sine x.
Not 2 sine x.
Sine x squared.
There you go. Sine squared x. Edu. Sure. And wait a minute. Where are we supposed to end at?
Right there.
Right there. That's the ending, right? We did it. We're done. That wasn't so bad. Let's do another. All right, let's see who's next. Will and Nathan, you guys already win. I'm going to skip your turn in the order. Billy and Alondra.
Get her done.
Yeah, get her done. All right, which side should we start on?
Go left.
I agree.
Let's go.
Now, you might be looking at this and go, Mr. Kulik, I don't like that fraction at all. That seems more complicated to me. Here's where I would disagree. On the left side, you have 2 things, right? You have 2 things being added. The right side, you have only 1 fraction. It's much easier to take 2 things and turn them into one thing than it is to take one thing and break it apart into two things. So even though that right-hand side is a fraction and that looks scary, I wouldn't want to go near that because I don't want to try to break it apart. I'd rather be putting stuff together. That tends to be easier to kind of find your way through. Okay? Jake and Hunter, we're working on the left-hand side. What would you guys like to do first? Are you thinking identity or algebra? Good, yeah, there's clearly nothing algebraic to do there, right? Just have two things added together that aren't like terms. Not much I can do with that.
You can break that tangent into TPC.
Okay, so that's a good idea and we can do that, but keep in mind where we're trying to get to. I don't have any cosecants or secants in my final answer, right? Instead, maybe use Q1 to write it as sine over cosine. And on that same note, maybe we worry about getting rid of secant at the same time, right? What would we want to do for secant? Excellent. Yeah, wonderful job. Everybody feel okay there? Now notice that, again, Jacob made a fine choice to start with by writing tangent as secant over cosecant. But keeping in mind where we wanted to get to, we rethought that, right? It was a good idea because you had a secant over there, right? That's good. But again, sometimes keeping in mind where we want to get to. Oh, yeah, you don't want that one. I want the other one. Okay, who's next? Allie and Emily. What are you two ladies thinking? Algebra identity. Emily, you're correct. You should do an algebra thing. What do you want to do? You have a common denominator already, right? So we can just add the fractions. So when you add fractions, the denominator stays the same, right? And then we add the numerators. What would the new numerator be? Sine x plus 1. That's great. I'm going to write as 1 plus sine x, but that means the same thing. That's wonderful. All right. Lucas and Peyton. Well, that's my first question to you. What are you thinking? Well, if I look at the final answer where I'm trying to get to.
But would you just like switch to put the this in the bottom?
Well, you can't just flip it for no reason, right? You have to do something algebraic here. But yeah, if you look, you have the right stuff over there, just in the wrong places, correct? So I wouldn't be thinking identity because I don't want to change my sine into something else or my cosine into something else because I need sines and cosines here. I have that. So I would be thinking an algebraic thing to do. And now this is going to be the sneakiest algebraic thing to do that we've seen yet. So look at where we're trying to get to. I would look here at the denominator. That's the denominator I want to have, correct? Do I have any way with an identity to change cosine into 1 minus sine x? Definitely do not. So how about we just put one of those in the denominator? A 1 minus sine x. How can I do that? Lucas? How can I just get a 1 minus sine x into the denominator, algebraically?
I have no idea.
Well, let's say you had a 1/2, and you wanted to change the denominator to like a 1/6. No. If I have a fraction with denominator 1/2, and I want its denominator to be 6 later, I want to change its denominator to something else. How do I do that? By to the top and bottom, right? No, not a reciprocal. Not cosine x. By what I want in the denominator. So if I do this, yes. That's just like multiplying by 1, correct? Does everybody see that? We haven't done anything really. We just multiplied by 1. Now what's going to happen? The denominator is now cosine x times 1 minus sine x. Cool, I got that 1 minus sine x in the denominator. What am I going to have to do with the numerator? Doesn't cancel to 1. You have to FOIL that out. Yeah. So when I look at these, does that look kind of familiar? If I think back to last year in Algebra 2, that kind of looks like a difference of 2 squares, right? You guys remember that factoring pattern from your Algebra 2 class? Whenever I see that, like a 1 minus something or 1 plus something, I often am going to look for a way to multiply by the conjugate piece so I get that difference of 2 squares thing happening. Almost always that's going to lead to something very good. So in addition to me looking at the denominator and going, I need a 1 minus sine x, I have no way to get it other than putting it in there myself. When I look at the numerator, that's the conjugate pair to the 1 minus sine x. I love the idea of multiplying the top and bottom by 1 minus sine x. It gets me the denominator that I need, or part of the denominator that I need, and I get that difference of 2 squares thing going on, which almost always is going to lead to something good. That was the trickiest step for a little while. If I'm looking at the rest of these, there's not too tricky of ones that are trickier than that for a bit. Joey and Edu, I think it's your guys up next. What do you want to do with what we've done, what we got here? 1 minus sine squared over cosine x times 1 minus sine x. What algebra would you like to do here? Yeah. So I think Joey was going to suggest we reduce, but then he noticed that I have a 1 minus sine squared and then a 1 minus sine to the first, which do not reduce. So he's changed his mind and gone with identity, which is a great decision. I like seeing that happen in real time where it's like, I'm going to do something bad, and it's like, wait a minute, no, I want to think over this again. That's not a good idea. What identity are you going to try? Excellent. Yes. So you're going to want to look at the numerator, because the denominator with that 1 minus sine x piece we don't want to mess with because we want that down there. If we use P1 to replace the 1 with sine squared plus cosine squared, and then we still have that minus sine squared on the top, Yeah, is it your turn? Oh, okay. I couldn't tell who said the comment. I was looking down. I was like, oh no, who said that? Okay, and then Edu's just going to finish this whole thing up, and now we're done, right? That's correct. Oh, we're done. Because they're the same. Remember, we have to always keep in mind where we're trying to get to. I like to say eye on the prize because always keep in mind where we're trying to get to there. All right, Nick and AJ, I think we're back up to the top of the lineup here with you guys. What side should we start on? They kind of look the same, right? Now, I would pick the left also. This is my reason. When I have a fraction, I would much rather have one term in my denominator than two terms. So I'd rather have just sine y rather than 1 minus sine squared y. The reasoning is, if I have just one thing in my denominator, I can break my fraction up at the arithmetic, at the addition and subtraction with a common denominator. But I can't break that fraction with the subtraction, the denominator at the subtraction. You know what I'm saying? Just gives me another option. So in general, I'd rather have simpler denominator over simpler numerator. That usually makes life easier, or gives us more options anyways. I don't think it would have made any lick of difference in this problem, though. But in general, given the choice, give me the simpler denominator than a simpler numerator. Okay. Billy and Luca, we're going to work on the left-hand side. What are we going to do with it?
We're gonna do
Great.
Should we do P1?
I wouldn't do P1 because if I replace that 1 with sine squared and cosine squared, yeah, let's do P3. There you go. All right. Joey, what's up? Why when I couldn't do that with the right-hand side and cancel the sine y's? Because I don't have sine y squared in the denominator. I have 1 minus sine y in the denominator. So it'd be like the same thing as saying, okay, I have like 3 over 1 minus 3. So I can cancel those 3's out, and that's just equal to 1. Can you do that? Definitely can't do that, right? This should be 1 over negative 2.
I thought you were about like across each
Uh,
other.
so if you're trying to prove an equality statement, you can only work on one side of an equal sign. And then secondly, this is not a multiplication symbol,
Yeah.
right? If it was those two fractions multiply to each other, you could surely reduce what you're saying. But here, it's an equal sign, number 1, and number 2, we're trying to prove the equality. So you can only, there's like a brick wall through the equal sign. You can only do one side. Is that, okay. Will and Khalil, what are you guys thinking?
The ones, can you just add them first?
Wonderful.
So that it's just
That's great. That's it for now. That's enough for you guys. That's a step.
like that.
Billy and Alondra. Or just Alondra. Yeah, say hi to Billy.
Oh.
Oh,
Now, Alondra, are we thinking identity or algebra? Identity is what I would do. Now, let's think about where we're trying to get to. I would be looking here and saying, okay, I need to get a sign in the numerator. So I would look for an identity using tangent that allows me to get a sign. I would use Q1 here, yes. You see how, like, at times I'm just going to look at this part of the problem rather than trying the whole thing at once. You just want to kind of chunk it a little bit. So using Q1, I can say that sine squared over cosine squared. And then instead of writing that as like 1 megafraction, I'm just going to write it times 1 over the old denominator. Is everybody okay with how I did that? Then instead of leaving that here and making a megafraction,
Wouldn't it be divided by? Just a fraction.
well, it would be divided by sine, which is the same thing as multiplying by 1 over sine, right?
Oh, yeah.
So again, I'm going to try to stay away from like megafractions and like division if I can. I just want to keep everything like multiplication if I can. Because it makes it easier to reduce, basically. Allie and Emily, are you guys the next in the rotation? Or is it Hunter and Jacob? Hunter and Jacob. Okay. What are you guys thinking here? Dynamic duo? Algebra identity. Well, we just used an identity, right? So I would at least check to see if there's anything algebraically that changing tan into sine squared over cosine squared can get me, right? Bill, you didn't take care of that sweatshirt situation that you told Miss Yarrow you were going to, and then I think forgot.
Yeah.
Yeah. Thank you. What are you fellas thinking here? You got any ideas? Just talk to me and like have the conversation you're having together aloud. We'll do it together. It's not a big deal. Great. Yeah, we're just going to reduce the fraction. So we can do that. That's good. So that leaves us with just sine y over cosine squared y. And now it can be Emily and Allie's problem. Before I ask you what to do, let's go back and look at where we're heading. Yes? So this is what we want to get to. The numerator is done, right? We have just a sine y in the numerator. So what I'm going to be concerned about is how do I turn my denominator, which is cosine squared, into 1 minus sine squared, which certainly has to be an identity. Like there's no algebra that's going to do that. So take a look and see what you can see. Well, I want to find a way to get a sine squared with the cosine squared. It's tricky. Look at P1 for a moment. P1 would say this, right? We have cosine squared. So if I try to get that cosine squared by itself, I could do something like that, right? So I'm going to call that like P1 star because we did a little bit of algebra to P1 to get it to look the way we wanted it to. And that's all we needed, right? To get us to the end. Now, we've just kind of discovered a new version of P1, right? We can say that cosine squared equals 1 minus sine squared. I'd write that down on my identity sheet next to P1 because I suspect we may want to use that again. Now, on the same token, I can say that sine squared equals 1 minus cosine squared. And I would write that down also next to P1 because that might be something we'd want to use again. In fact, we've already used them. If you go back and you look at the previous problem, look at what we had right here. What did we eventually turn that into? Cosine squared. Right? We already kind of used it. We just didn't acknowledge that it could be its own separate thing. So again, I highly recommend on your identity sheet you write down sine squared equals 1 minus cosine squared and cosine squared equals 1 minus sine squared. And you are free to use those as P1 whenever you like. So you don't have to rederive it or anything like that. That's free for you guys to use whenever, wherever, just like Shakira said. It's a reference to a 20-year-old song that nobody laughed at. Yeah, that's fair.
Cosine squared.
You go back to like 2003, that would have gotten all the laughs. Joey and Andrew, I think you guys are next, right? Which side? Great. This was a no-brainer, though, so I'm going to ask you what to do next after that. Algebra identity. Okay, great. What are you going to do? What did you say? Well, you have to be careful here. How do you square a parenthesis like that? You have to FOIL it. Yeah. So I'm just going to write down this extra step so everybody is clear, like, what I mean. So what I did here is I just wrote out the FOIL problem, right? I didn't actually do anything. Now let's FOIL this out. I'm going to do that in my head. Now you can always first, outer, inner, last this thing if you'd like. I'm going to save you guys the hassle. Because I trust at this point that we can FOIL things. Maybe I'll regret trusting that we can do that, but we're going to go with it. AJ and Nick, you guys are up. I'm going to give like a minute because everybody's probably still writing at this point that's following along, because that was a lot of symbols to copy. But as you're writing, if you can start, doing a little light brainstorming. The first question I'll ask you is algebra identity. I agree. What are you going to do, AJ? Combine all the like terms. I have a cosine squared t and a second cosine squared t. That gives me 2 cosine squared t's. I have a negative cosine t sine t, or negative 2 cosine t sine t, and a positive 2 cosine t sine t. Those will cancel out. And then I have a positive sine squared t and another positive sine squared t. That gives me 2 sine squared t's. Well, heck, that looks a heck of a lot better now. Who's stuck on that list? Is Billy and Alonso, is that right? Oh, Luca and Billy. Luca and Billy.
We're going to go to identities. So,
There is something you could do algebraically. Can't combine the 2's, but it's related to the 2's. The 2's are a greatest common factor. So we could do this. And now look for an identity, Billy. Yeah. And that's exactly what we need to be done. How are we feeling on these? Is this basically still the same thing as last time, right? It's in a way it's easier because you have the answer that you need to get to. It's just about, can I correctly manipulate the algebra and apply the identities to get to what I need to get to? It's a little bit like a puzzle, right? Like, how can I fit these puzzle pieces together to get to where I want to go? All right, let's see. Okay. Will and Nathan, 51. What side? Would you say, Nathan? Could do either side. It's going to make no difference whatsoever because they basically look the same, right? Great. So for the sake of argument, let's pick the left side to work on. What would you want to do first? Identity or algebra?
Identity.
Well, what identity were you thinking? I think probably Q2 would be what you'd have to use since you have cotangents.
Oh, yeah.
Now you could do this, what you're recommending. There's a much easier way.
Can you do like cotangent?
No, there's no reducing that you can do. But this is what I'm going to look at. I have a -1 over here, and I need it to turn into a minus tangent over there. I have a +1 down here, and I want to turn it to a plus tangent over there. Hunter, do you have an idea? I'm not going to do R6 either. Well, at least not yet.
Do the same thing that we did with the other problem. Just multiply by what you want with the denominator to be.
I'm not going to do that. I'm just going to multiply the top and bottom by tan. Now, Hunter, I am going to have to apply. I am going to have to use that R property that you're suggesting. I'm just going to do this first because I think it'll make it a little bit more obvious why I need to do that. This is a wonderful, wonderful trick that I'm about to do, which is going to allow us to do this problem with virtually no fractions, and certainly will not require any common denominators or adding of fractions or any of that stuff, which, again, not that I mind it, but if I don't have to do it, like, thank you very much, like, let me not do it. Now that's a sneaky, sneaky trick that we just pulled there. Notice that what we accomplished. I now have the minus tan on top and the plus tan on bottom. So I know somehow this stuff both needs to become 1s, right? Where are we at in the rotation now? Now it's Billy and Alondra, right? Yes. So again, we're looking at that cotangent times tangent piece, and we know that has to turn into 1 somehow. The only way that's going to be able to turn into 1 is through an identity. So let's look for an identity that we could apply here. Well, I wouldn't be looking at the Pythagoreans because I don't have anything squared, right? The Pythagoreans all need like sine squared or cosine squared or secant squared or tangent squared or whatever. I don't have any squareds. Yeah, let's look at the reciprocals. That's 100% where you want to be looking at. And it doesn't really matter. You could use R3 or you could use R6. It doesn't matter. Let's say we use R6. That allows us to rewrite cotangent as 1 over tangent. And if we multiply those fractions, we can, anybody. What's it called with what I'm about to do? Reduce, not cross multiply. It's called reduce. And we're done. Now that's sneaky by choosing to multiply the top and bottom by tangent. That was a sneaky move, Mr. Kulik. But look at how nice and neat that went. I did one identity and a little bit of algebra, and I'm done with it. That could get real messy in a lot of ways. If you start by writing everything using the quotient identities and sines and cosines, and then make some common denominators and add some fractions and multiply by a reciprocal and combine some and just like, it can go on for a while. I did it with one identity. Now, as you're seeing these problems for the first time, is that a reasonable expectation for you to notice that right off the bat? No. But as I'm showing them to you, should you be keeping in mind, like, oh, maybe there's just some like sneaky thing I can do with some multiplication with and get to what I need. When we show you these tricks, they should go into your little file box of like tricks that you can use. That like when you get to a problem, it's like, oh, I can see what to do here, but it looks like it's going to be messy. Maybe go back and look and see if there's a trick that we've seen before that you can pull out and allow yourself to like avoid some yuck, right? All right, let's see. What do we got here? So we still got some time. We're doing good on time here. Let's see. Who are we at now? I don't remember. Alondra, you and Billy just, so Jacob and Hunter. We're going to start with you fellas. Where would you like to start? I would agree with that. Again, I'd rather combine two things into one than try to break two things apart into two. What do you want to try to do here? So let's look at where we're trying to get to, right? We're trying to turn this into a multiplication problem, right? The only way to turn an addition and subtraction problem into a multiplication problem is at some point we're going to have to factor. That's the algebraic tool that's going to take two things added together into two things being multiplied together. So what I would be looking for here is an identity that would allow me to get a common factor between the tan squared and the sine squared. Excellent. Yes. So I would be looking for Q1. That allow me to write tangent as sine squared over cosine squared. And now if we look, as I mentioned earlier, if I think about sine squared to sine squared over 1, I have a common factor between the two terms. That common factor being sine squared. And in addition, something lovely has happened because I finished kind of half the problem, right?
How'd you get that? How'd you turn that?
So I found they both terms had a greatest common factor of sine squared.
Wow.
So when I factored that out front, sine squared over cosine squared becomes 1 over cosine squared. And the minus sine squared turns into minus 1. Right? If I distribute the sine squared back through, I'd have exactly what I had before. Does that make sense, Billy? So I'm really excited about the progress I've made so far because like half my problem is done at this point. That's fantastic. Who's after you fellas? Allie and Emily, right? All right, ladies. So somehow that stuff has to turn into tan squared, right? What are you girls thinking? Emily, you want to do algebra identity here? Okay, what algebra would you think you'd want to do? The only algebra thing you could do would be to make a common denominator, which would not be wrong, but there's going to be an easier way to get to where we want to go than doing that. But I want to be clear. Not wrong to do. You'll get to the finish. I think you'll use an extra step probably to do it, but it would not be wrong to do that. Let's look for an identity instead, though. Now, specifically, the thing that I would be looking for is trying to find a way to make that not a fraction. Because when I look at my final answer, there's no fraction in the final answer, right? Say it, Allie.
I don't know. There's two.
Okay, which two are you thinking?
Maybe.
Say it loud so we can all hear it.
Now I don't know.
Say it loud so everybody can hear it.
R5.
R5 is what you want to do. That is correct. That is what I would do. That allows us to turn the 1 over cosine squared into secant squared. Okay. And then Joey and Edu, you guys are next in line, right? That allows us to use P3, which is going to turn that into tangent squared, and we are at the finish line. All right. Let's do one more, and then we'll probably call it quits for today. I think we have like 10 minutes left. That feels pretty good, right? You guys feel like you're getting better at this? At least like building some intuition as to like where to go, what to do. You're giving me lots of good answers. I can tell you're thinking hard about this, which is great. That is the first steps. Now, it helps having Mr. Kulik like do everything correctly when you tell me what to do. Like he does all the symbol manipulation correctly for you. So it is going to feel a lot harder when you do these by yourself because you'll have to make sure not only are you doing the right thing, but you're actually doing it the right way, like you're manipulating the symbols correctly. All right. Who were we at? We're at AJ and Nick, right? All right. Which side? I agree. What are you going to do on the left side? Algebra or identity? Okay, what algebra thing are you going to try to do there? What do you mean by reduce? There's no fraction. What? Oh, what? Yeah, great. How are you going to do the factoring? Or what factoring are you going to do, I should say?
Oh, wait, can you just? Can you make it into two differences of squares?
Yes, so that's exactly the way you want to think about this. Let's rewrite it this way. So let's think about it as cosine squared, squared, and sine squared, squared. So now this is in the form of a difference of two squares, right? An a squared minus b squared. So we know that factors to a plus b times a minus b, right? Where my a is going to be the cosine squared, and my b is going to be the sine squared. Does that, everybody kind of see that? Great job. That's tricky to see. You did it like, didn't even really give you any kind of nudge in the right direction there, so that's great. So there's my factoring. Billy and Luca. What should we do next? Sure, no worries. Well, if we FOIL, we're going to end up back where we started.
Oh, we just back.
We just factored, you're right. Yeah, so if you look where we're trying to get to, we have that right there. And if we look at what this is, that's just P1. So that's everything we need. And we're done. Pretty righteous, right? How do you guys feel? We did a good chunk there for you guys, right? Together as a group. It was like 6 or 7 of those.